With that, let's move to our final presentation of the conference. Stuart Midgley from Duck. How are you, Stuart? Thank you for hanging in there.
No problems. Good, thanks. Okay, so I've got a small presentation. I was going to talk about a little bit of an update on what we're doing in Geraldton, but I've sort of morphed it into more a talk about energy and placing what we want to do in a larger context. So let me go here and share my screen. Share. Can everyone see a nice orange page with an outline of Mark in the picture? Fantastic. Okay, so for those who don't know us, a brief overview. We're an ASX listed company. We are a startup to ASX listed company story. Our two founders, which you can see there, Matt and Troy, started us back in 2003. And I guess we've been on a journey in high performance computing for almost 20 years. To where we are now, where we're a couple of hundred people. We're obviously headquartered here in Western Australia, and we're designing, building, owning, operating some of the largest and greenest supercomputing facilities around. So I thought I'd give you an update on what our plans for the future are. We have a few business lines: national security and space, oil and gas, which is sort of our legacy data processing business, and enterprise, which is where I'm putting a lot of effort at the moment. We do software development and sell high-performance computing software. We've got 40 plus software developers here in Perth. We're doing high-performance computing as a service, so large green facilities and selling compute time on everything we have. And we do data processing services, predominantly in the oil and gas sector, but we do go wider than that. And we wrap it all up and deliver it under a package called Doug McLeod. As people may know, we are a global company. Our headquarters in Perth, but we have large offices in Malaysia, the UK, and in Texas in the US. Our largest current compute facility is in Houston. And if anyone's going to supercomputing, I extend the invitation, get in contact. You're welcome to come to Houston, see our large immersion cooling data facility, see a few hundred tanks deployed, and I'll be there for the Wednesday, Thursday, Friday before supercomputing. So happy to host people. And what I'm going to talk about is this large green high-performance computing campus just north of Perth in Geraldton. So that little green cloud in that diagram. We have a diverse customer set, people who buy software, high-performance computing as a service, and people who buy our data processing services. And we have customers who function in all of those areas. So if you look, there's Equinor, large oil and gas company, uses our software, buys our software, high-performance computing as a service, and our data processing services. And I guess one of the things which we've been spending a lot of time and effort on recently is security. So we have security as our highest priority, securing high-performance computing facilities, being a sovereign capability, and wrapping it all up. We managed recently to get ISO 27001 certification and ISO 9001, which is a fantastic effort by our team here in Western Australia and globally, and I think really sets us apart as a high-performance computing facility. All right, so corporate stuff out of the way. Let's talk energy. So I'm a physicist, and everything is really energy. So that's really what my focus is. That's what our immersion cooling technology is. And so this is where I wanted to start a talk about data centers. So on the left, we have a Bugatti Veyron. This is a supercar from about 2015, weighs about 2 tonnes, takes about 5 cubic metres, costs about 3 million Australian dollars to buy. But more importantly, it's 1,000 horsepower or about 800 kilowatts of energy. To put that into perspective, that's about 2,500 A100s. Now, if you took 2,500 A100s, it would weigh about 3.4 tonnes. Stacked up, one on top of the other in a space, it'd be about 2.8 cubic metres and cost you about $50 million. So you can have a Bugatti Veyron, or you can have a high-performance computing facility. Another perspective is the Bugatti Veyron is equivalent to about 1,000 households worth of energy. So I jumped onto one of the energy sites in Australia and worked out from some of their stats the approximate average energy 24 hours a day, 7 days a week a household uses. And so 800 kilowatts is about 1,000 households, which works out 800 kilowatts needs about 2,200 solar panels. Or if you want to run 24/7, about 6,500 solar panels. To give you some idea, the approximate size of a solar panel is about 1.7 square metres. 2,500 or 6,500 solar panels adds up to about a hectare. So if you want to power your Bugatti Veyron on solar panels, you're going to need about a hectare of space. So that's 100 metres by 100 metres. So think about Olympic swimming pool is what, 50 metres by 30 metres? So it's 2 Olympic swimming pools along each side. The Bugatti Veyron costs about $2.1 million a year to run on petrol if you ran it 24/7 at a rough 800 kilowatts. It's about $1.2 million, $1 to $2 million a year, in electricity to buy that anywhere in Australia. So whether it be Perth, where electricity is a bit cheaper, will be more towards the $1 million range. But if you go to the eastern seaboard, you're going to be pushing up towards the $2 million range. So that just sort of gives you some idea about energy and how much it takes, because of course the Bugatti Veyron at 800 kilowatts megawatt sort of range is roughly the size, from my estimates, of each of the HPC systems in Australia. Now that might be NCI, Pawsey, Defence. It's about that sort of size, give or take a bit. Another comparison. So we've got our HPC facilities. They're using about 800 kilowatts to a megawatt, around that sort of number. Some might be pushing towards 2. With immersion cooling like we do, you'll be at the megawatt, but it's actually about equivalent to 2 megawatts elsewhere. But what does colo do? We saw some talks earlier today where we were talking about hyperscalers. So how much energy do they use? Well, here in Perth, we have a data centre, a big black box on top of the polypipe here in WA. And it's about 12, from the documentation I could find on the web, it's about 12,000 square metres of IT floor space. If you read the documentation carefully, it's running a 1.5 megawatt UPS. So you can be pretty sure that its energy consumption is less than a megawatt of actual IT load. It's got a design spec of about 20 megawatts. So at about a peak, they're doing 4 kilowatts per square metre. And at the moment, they're averaging about 1.7 kilowatts per square metre. And they're doing it at a PUE, according to the documentations, of 1.2, 1.3, those sorts of numbers. If you look at our facility in Perth, which is the orange facility you can see there, we're 110 square metres as opposed to 12,000. We have just under a megawatt of IT load. We've designed for a megawatt. We're running at 8.5 kilowatts per square metre of actual current right now energy usage, and we're doing it at a PUE of 1.04. So that's quite a big difference. A lot less floor space, and roughly the same amount of energy, but at a much higher density. And so if you want to compare high performance computing to everyone else, that's a good place to start, energy density. Of course, I went and thought, well, what's the largest data centre in Australia? And again, it's the same company, a big black box. They've got a 20,000 square metre facility in Sydney. And their total UPS is only 2.7 megawatts. They've got a design spec of 80 megawatts, which equates to about 4 kilowatts per square metre, but they're using way, way, way less than that. And they're doing it at a PUE about 1.2. So again, if you think about our Australian HPC facilities, they punch way above their weight in terms of energy for the amount of floor space that they throw at the problem. For me, that's always been a very striking idea of HPC data centres, is just the energy density we have to deal with. How does that compare to the top 500? Well, I went and grabbed the list and I put the top 10 machines there on the right. And so you can see the largest energy use is for Gaku. It's doing about 30 megawatts. Frontier, which is roughly 3 times the compute capacity, is doing it in 21 megawatts, right down to the number 10, which is 0.9 of a megawatt. So most of the Australian facilities in terms of energy usage are at about that number 10 spot. Add them all up, the top 10 aggregate to about 111 megawatts of energy. I've done a similar calculation where I actually took all the top 500 and you add up the energy. And it's a bit more, but not a huge amount more. So you can probably, it's about 100, I think it's about 170, 180 megawatts for the top 500. So big numbers. But again, I think if you go back to the design of some of these big black boxes, which, 80 megawatts for this facility in Sydney, but they're only operating at, under 2 of IT load. Whereas these HPC facilities, if they're designed at 30 megawatts, they're probably using 32 megawatts. Most HPC facilities try and eat into that electrical design and the buffers that electricians seem to like. Now, to give you some idea of what we want to do in Geraldton. So our facility that we're planning in Geraldton will be about 8,000 square metres of IT space, and we're looking at about 108 megawatts of design. So that's about 135 Veyrons, if we want to sort of measure it that way. Again, we're targeting, as we have here in Perth, about 8 kilowatts per square metre, and we're targeting a PUE of 1.03 or less. Now, the other half of what we do with immersion cooling, of course, is that with immersion cooling, we save about 50% of the power bill. So that 100 megawatts of IT load would be about 200 megawatts if we put it all in air. And so that sort of probably gives you an idea of, in comparison to the top 500, of what we're looking at building, a facility which could take all of that. Interestingly, of course, the top 500 energy usage has been going up quite significantly over the past couple of decades. So it is interesting to watch how much energy these bigger machines are consuming. So we all know then, obviously, that energy use and carbon footprint's a big thing. The astronomers did a big study on it, and so the green aspect is really important. And I guess what a lot of people don't appreciate is some of our largest customers are really, really keen on our green credentials. Oil and gas industry is going as hard as it can to have as many green credentials as they can. And so what we're doing and what we plan to do in Geraldton is obviously gaining a lot of attention in those industries. So obviously the greenest power is the power you don't use. That's what our cooling technology is all about. It's all about reducing power and then fundamentally reducing the number of solar panels and reducing the number of wind turbines. If I go back, I'm just going to quickly skip through these to this picture here where we talk about the number of solar panels. So again, for every roughly megawatt of energy for your data centre, you're going to need about a hectare of space for your solar panels. So to power your average Australian HPC facility is going to take about a hectare of solar panels. So it's a significant amount of space. If you want to build 100 megawatts, you need a lot of space. And so if saving half of that energy is very, very, very important if you want to go big. The other aspect of what we do is that we don't use refrigeration. So we don't have any of those fluorinated gases and synthetic refrigerants, and we just don't waste energy. We hit very low PUEs. And so the idea of Geraldton is to use that technology and then couple it with 100% renewable energy and energy storage so that we can actually run 24 hours a day, 7 days a week without any grid power at all. The other aspect of Doug Cool is we save a lot of energy, we save a lot of refrigerants, but also we save a lot of water. Again, most data centres dissipate the heat to the atmosphere in the end through water. So they might have refrigeration-based systems, but then they'll couple the refrigeration-based system to an evaporative cooling-based system to get their efficiency up. So a lot of these data centres pump a lot of water. We're no different. We use a lot of water. In Perth here, we don't use much because it's mostly dry cooling, but certainly in our Texas facility, which is our largest, we use a lot of water. But again, using half the energy means half the energy needs to be dissipated to the atmosphere. So it's a lot less water, which of course will be important in Geraldton. As I said, the aim is to have this facility up and running 2023 to couple immersion cooling with green energy, wind and solar, and energy storage. We aim to hit very large numbers in terms of capacity and then build it out as time goes by. We've got a site, we've got a plot of land in Geraldton. And where is that picture? Here we go here. It's sort of, you can just see it on the left there, and just to the top right is the Geraldton Airport and TAFE just above. I'll get to that in a sec. So again, why the Midwest? I mean, people ask me all the time, why Geraldton? And I guess the answer is really, really simple. First of all, Geraldton and the Midwest and Northwest of Western Australia are becoming a globally important energy hub, shifting from oil and gas to renewables. There's an enormous quantity of wind and solar. If you haven't been to Geraldton, the trees grow sideways. It is one of the windiest places on earth. The other thing that Geraldton is really interesting for is there's a lot of fibre that goes through the place. Western Australia is the eyes and the ears of the world for the southern sky. And so you have an awfully large number of space agencies, satellite companies, etc., functioning out of Western Australia and shipping the data back across the world. So there's a lot of fibre, and West Australia is becoming critically important to the global networking infrastructure as people come across the Middle East, Southeast Asia, hit Singapore, and then preferencing coming south through Australia across to the US rather than north. Again, we need space. You know, for every megawatt, you're going to need about a hectare of land. We've got 65 hectares, so we can do a fair amount, but you need a lot of space to do wind and solar. And Geraldton's got plenty of that. It is, networking-wise, effectively the same as being in Perth. You're about 3.5 milliseconds away. There's a great labour force, and it's a well-educated labour force. So we have electricians, plumbers, etc. We've got people who can operate a data centre. And because it's a large town, it's got normal construction costs. It's not like you're trying to build out in the middle of the desert. And through our relationship with the Yamachi Nation peoples, there's a large political goodwill, and there's also, going along with a lot of that, is a large hydrogen push in the region. So we wish to participate. As I said, we've got 45 hectares near the airport. It's owned by the Yamachi Nation. ARNet has fibre going into that little TAFE box. And so we can, as we've done here in Perth, where we're connected to ARNet, we can be well connected to ARNet and then the research infrastructure in Australia. This space fits all of our requirements. Plenty of space for solar. We can put considerably sized buildings on it. It's stable, all those sorts of things. The aim is, at the first stage, is to get data hole 1 up, which will be about a 20 by 60 metre building. And you've sort of got a rough schematic of it there. And this will also have, a bit of a foyer and boardroom and visitor centre, etc. So the other part of what we're doing is actually we're actively engaged in energy research. So we're working, again, targeting what we're going to do in Geraldton. We're targeting the vendors, making sure everyone's coming onto immersion cooling. We are targeting the fluid vendors. So recently we have got new fluids which are performing significantly better, and we're now just going through the benchmarking process with those. We are seeing vendors right now starting to adjust their designs for immersion cooling. So this is a future we see coming more broadly than just what we want to do in Geraldton. The nice thing about what the vendors are doing, and both the hardware vendors and the fluid vendors, is it's ultimately allowing us to increase that input water temperature. So the warmer we can have that input water, the more efficient we get. At the moment, we're at about 30 degrees, but the higher we can push that, the more efficient we're going to become in terms of how hard we have to run the cooling plant outside the buildings. So all of these advancements are making a significant difference. And I guess from my perspective, I'm calling it the Geraldton inversion. This is not our formal name for it, but I see this as a really interesting step. So most data centers have a grid power feed, and then they have their own power generation sitting alongside it, mostly turned off, being unused, but being maintained. What I want to do is invert that. I want to have that main power source sitting alongside being used and running the facility. So what other people would call backup power, I want to be my main power. And then use the grid as backup, and then have someone else maintain the grid. So my power that I'm using is being maintained by me and being used by me, and we can predominantly run off grid. By doing that, obviously we can completely redesign how the facility works. So where a lot of facilities spend a lot of money in the UPS, that will just be our power source, and we will not be paying anyone for it. And then when we use the grid, it might be slightly more expensive, let's see. But at least then, hopefully we don't have to use it. And so the thing that we don't want to use will just be sitting there waiting, and us not having to maintain it so much. The other part, and this is where we can go climate positive, is that we can then actually assist the grid. So put energy back onto the grid when the grid needs more energy, and potentially take energy off the grid if we've got energy storage on site, take energy off the grid when it's got too much. Rather than, as they do here in Perth, they quite often just turn the air conditioners and the lights on at Optus Stadium and run it during the day, even though no one's using it. It'd be great to be able to use that energy. All of this adds up to being better for the environment, because we're using half the energy that you normally need. It's less solar and wind turbines, etc. And the other part, all of this, by placing in Geraldton where our generation is, we'll also be able to cut down transmission losses. So most of the time you do lose transmitting power from distant places into the city. You do suffer a lot of transmission losses, and that's captured in your price. So hopefully we'll be able to make that effectively zero, which is better for the environment. So this is roughly where we're going. I want to flip the data center upside down. As I said, have what people consider the backup power supply as our main power supply, have that all green, and use the grid as our backup. That's the dream. So we're rapidly heading towards that. Of course, what does this really mean? Fundamentally, this allows us to deliver our high-performance computing as a service into industries globally, provide a lot of the infrastructure that people commercially want to run on, whether it be for research, whether it be for commercial workloads or whatever, and do that in a very sustainable fashion. All of the vendors that we work with are pushing on the sustainable boundary, whether that be the hardware vendors and fluid vendors. We have got a fluid which is sustainably sourced. So there's a lot of activity in this space, which is getting really exciting. Love to have people along on the ride. If you want to see our immersion cooling, come and see us either here in Perth, you can see us in Malaysia, or you can see us in Texas. And that's all I have at the moment. Thank you.
Thank you, Stuart. Appreciate the presentation. I currently don't have any questions. Does anyone have any final questions to provide Stuart over here at Doug? You can use the Q&A or the chat panel.
It's getting late in the Eastern Seaboard.
Not as late as it is here, but Gabby and I are hanging in there.
Yeah.
We're doing good. So you're going to SC, obviously.
Yes. We've got a booth at Supercomputing, spruiking our wares. So seeing what people are up to. I've got a lot of meetings and talking vendors. Obviously, a lot of the vendors we work with are catching up with in Houston, April. So looks like a good show.
Fantastic. Yeah, we're all hoping things start returning back to normal. Stuart, I don't have any questions coming up, so thank you again.
Oh, thank you very much. Nice to speak to people.
All right, so this comes to a close. So I'd like to thank Sean Smith at NCI and Mark Stickles at Posi for co-hosting this conference with us. We appreciate all the great support both supercomputing centers have provided us over this past half decade, and we look forward to more cooperation between the organizations. Thank you to all our speakers for the great presentations yesterday and today. We'll be posting videos and slides of each session in the coming days on our YouTube channel and also the Australia Conference website on the HPC Advisory Council website. I'd like to thank again Karina Nunes, Ann Backhouse, and Aditi Subramania from PASI, and Liz Williams and Seth Chandri from ANU NCI for all their support of this conference. Really couldn't have put this on without you. And of course, thanks to Gabby here at the HPC Advisory Council for helping put this virtual conference together. This concludes the HPC AI Advisory Council Australia Conference. I hope everyone has a great week here at PCon 22, and we look forward to seeing everyone in person next year. Thank you again.